is the end of today's session. We talked about removable discontinuities, and it was honestly just a review of what we've been doing throughout the whole entire session, which was that we've been looking at whole discontinuities, right? And so it works today. This is my whole discontinuity. And let's say this exists at 0.5, right? At a value of 7, right? We've been talking about this idea that the limit. Let me do this in a different color. Let me do a different color. Here. The limit as x approaches 5 of my function f of x is going to equal 7, right? From both sides, as I approach this function, we're going to get to 7. But what we talked about, which seemed to confuse people, was that since this is a removable discontinuity, we can remove it. Essentially, what I'm saying is we can define a new function such as z of x that does not contain the whole. So what I said essentially was that z of x, right, this new z of x, whatever it can do is fill this hole in. Because originally from f of x, remember f of 5 is undefined. What my goal is I want z of x to equal 7. Now, one of the ways that the AP exam will like to ask you this is that in order to cover this hole, right, the value of z of x is the limit of f of x. So let's write that down because I feel like that is where all the confusion rose. So on the AP exam, the statement you need to be familiar with is that z of 7, right? There's not z of x. This should be z of 7, actually. Right? Because as z of 7 of my new function is defined, unlike not z of 7, z of 5. Z of 5 it should equal 7 because f of 5 is undefined, right? F of 5 is undefined, but we want z of 5 to be defined. So on the AP exam, we're going to say that z of 5 is just equal to the limit as x approaches 5 in f of x, which is also 7. So at the end of the day, everything is equal to one another. Right? 7 equals 7 equals 7. That's our goal. But the way that we have to, the one of the other ways that we can cover this, right, is how does d of x look like? That's the main question now. How does d of x get defined? And one of the ways we can do this is with a piecewise function. Now, my notation may vary. I'll start using consistent notation, but the one I'm about to show you is just fine. We're going to say that z of x is going to equal a piecewise function. Let me do my symbol correct. All right. I'm going to say that we're going to be everything of f of x only except the case where x equals 7, x equals 5. So realize when we have our whole discontinuity, right? when there's a hole right here, I don't want f of x to be listened to. Instead, when x does equal 5, I want it to be 7. Or more specifically, I wanted it to be the limit as x approaches 5 of f of x, which we know is 7. So I'm just going to redefine this with 7. So look, it's not that complicated of a idea, because at the end of the day, we're just supporting this statement. Which is why I like to emphasize this statement, is that for our new function z, we're just relying on the limit. We rely on this, right? We're just relying on this limit to give us the value to z of 5. This is how we prove that we can remove the discontinuity. So often the question will only ask you, so the question you just have to be familiar with is how to remove the discontinuity. How to remove discontinuity. And if you have a function like, let's say, g of x equals x minus 4, you can see here that we have a discontinuity case, right? X equals 4. We know that we have a hole at x equals 4. But what we can do is say that if I take the limit, I know that the limit as x approaches 4, my hole, of g of x is equal to, what would this equal? This would just equal 4, right? So and the way I know this is through direct substitution. I should probably clarify that. But another way you can know this is that this is a straight line. I won't get into direct substitution, but let's just assume you knew the graph, right? So at 4, we get 4, okay? And that's how I knew this part. So for our new function, right, the way you can remove this discontinuity is simply remove by saying my new function, let's call it h of x. H of x at h of 4, I know I'm just going to use the limit as x approaches 4 of g of x, which will give me 4. So this statement again, same statement, right? Become familiar with it. Rounds perfect. And same thing here, right? Relying on the limit to give you the actual value, right? Just a way to prove it and to say the same exact thing twice. Hope this helps.